Hello, my name is Alexander Vallejos, and today we'll be talking about the AC, and in particular AC sine wave. To understand what AC sine waves are, we must first delve into what is AC. AC, or alternating current, unlike its counterpart DC, is constantly fluctuating and is defined as a form of electric current where the current periodically changes its direction and polarity numerous times throughout its cycle or cycles. To portray this behavior, where the AC changes from positive alternation to negative alternation, the graphical representation of AC is a sine waveform. An instrument that is used in the field of engineering that depicts the AC sine wave is an oscilloscope. Here are the characteristics of the AC sine wave. Firstly, there is a voltage amplitude or peak amplitude. This shows the maximum voltage in the circuit and is the value from the peak to the average. Secondly, there is a voltage peak-to-peak value. This shows the full voltage between positive and negative waveform. Thirdly, the period, represented by the symbol T, is the time elapsed for one cycle of the waveform, and its SI units is seconds. Lastly, frequency. This is the inverse of the period value and shows the amount of waveform cycles per second. Therefore, it is given by the formula frequency equals 1 over the period and is represented by the SI units Hertz. Here is the general form of the AC sine wave. The formula is the amplitude times sine of brackets omega times the period plus or minus the phase, where omega, or the angular velocity, is given by omega equals 2 times pi times frequency, or 2 pi over t. And phase is the relationship of the waveform. The phase represents the phase shift of the waveform along its horizontal axis. A negative phase means the waveform is shifted to the right and the waveform is leading. A positive phase means the waveform is shifted to the left and the waveform is lagging. Here we'll now go through an example. The peak amplitude is 8 volts. Since from the average 0, the highest value, the maximum value is 8 volts. Secondly, the voltage peak-to-peak value. Here it is 16 volts, as we have got from 8 plus 8 volts. Thirdly, the period. Here we can see the one cycle is 0.4 seconds. And lastly, the frequency, which is given to us by 1 over 0.4 seconds. And this amounts to 2.5 hertz.